Hi guys, this is Mrs. Gassler, and in this video we're going to talk about acids and bases, as well as their definitions, how we define those, and a couple of different ways to look at them. We will not be talking about pH scale in this video. You'll have to watch another video to learn more about the pH scale. So we're going to go ahead and get started. If you want to pause and make your note paper look like this, and then get started, you certainly can. I'll leave this here. Alright, so here's what we're going to do. First off, we're going to talk about the properties of acids and bases. First, acids. Actually, we'll compare them both at the same time. Okay, acids usually taste sour. In fact, the reason sour candy tastes sour is because they've covered it in an acid that makes it taste that way. Bases, on the opposite side, taste bitter instead, and sometimes people describe those as tasting metallic. Something that acids do is they turn blue litmus red. They don't turn red litmus any color. Bases on the other side turn red litmus blue. Okay, blue for basic, if you can remember that, that might help you out to keep those two straight. Another thing that acids have in common with bases, sort of, is an acid can neutralize a base, where a base can neutralize an acid. That means that neither the solution, if you mix an acid and a base together, the solution that you get in the end will not be acid or base, but somewhere in between. And then something that's not exactly common or whatnot, bases tend to feel slippery. So if you get a base on your fingers, if you've ever accidentally gotten bleach on your hand, you remember how smooth it makes your fingers feel? That's a sign of a base. And acids can dissolve metals. Bases don't dissolve metals, but acids do. Okay. So we're going to talk about some definitions of acids and bases, and there's two guys that we're going to be focused on in our unit. There's a couple of other definitions of acids and bases, but they're similar, just a little bit different. We're going to talk about this Arrhenius and Bronsted-Lowry acids and bases. So we're going to compare them kind of next to each other. Okay. So in an acid, according to Arrhenius, these guys produce H+ ions when you put them in water. Okay, the number of H+ ions increases. We'll talk about what that means here in a little bit. Bronsted-Lowry says that it kind of does the same thing, but they call it a proton donor. Okay, so if something donates a proton, then it is an acid base. But the proton that it's donating is an H+. Okay, so they're kind of doing the same thing here. You'll see the real difference. They're kind of the same as far as acids go, producing the H+ ions and giving up a positive ion there. With the bases, they're a little bit more different. So here we go. With a base, Arrhenius says that they produce OH- ions. It's called a hydroxide ion. When you mix it into water, there ends up being more OH+ ions in there than not. And the way Bronsted describes these is also the opposite of his definition. It is a proton acceptor. Okay, that means it takes the H+ ion. Okay, so slightly different thought process here, but they're kind of similar. We'll talk about that more in a little bit. When we talk about acids and bases, according to the Arrhenius one, what happens is that an acid plus a base, when they mix, they form a salt and water. And something you need to know about the salt is that it's not necessarily table salt. It could be any kind of salt. In fact, a salt is sometimes defined as what's produced during an acid-base reaction. So salt and water. So we've got our H2Os there. When we talk about a Bronsted-Lowry acid and a base, what's really interesting about those is that it depends on what you mix it with. It depends on what it's mixed with. And what happens is that sometimes sometimes a substance is an acid, and in other situations it's a base. So sometimes it's an acid, and other times a base. The same substance could be one or the other, and the term for that is called amphoretic. When it can be either an acid or a base, depending on the situation, it's called an amphoretic. So water is a good example of an amphoretic. Sometimes water is accepting the proton, and sometimes it's donating the proton. So sometimes it's the base, and sometimes it's the acid. So now the reason all this happens, and the reason these definitions kind of work, is because of this thing called the autoionization of water, and that's literally what that means is that in water. Water molecules dissociate too. Water molecules dissociate and recombine, so they're coming apart and together, and sometimes they do this interesting thing where if you have two water molecules, okay, they can turn into this thing here. One of those hydrogens leaves one of these waters and joins the other one, and then the other one is left missing a water. Okay, now this thing right here is called the hydronium ion, and the hydronium ion is used kind of interchangeably when we talk about things with the H+. So if you hear somebody talking about the H+ concentration or the hydronium concentration, they're talking about the same thing. This guy over here is the hydroxide ion. They both have the same charge, so these things stick together, but they're combined differently. So we have some exchanges here. Now in water, it also goes the other way. The hydronium loses its hydrogen and it goes back to oxygen. And so in water you have kind of an even amount of everything, and so that actually is what makes water neutral. In this situation, here's a good example of this amphoretic here. So let's see if we label them here. This one is if maybe it's the one that's gaining the hydrogen. That means it's a proton acceptor, which makes it a Bronsted-Lowry base. This one over here, though, is losing the hydrogen, which makes it the Bronsted-Lowry acid. And then on the other side, this one is giving up the hydrogen when it loses it, so that one is the Bronsted-Lowry acid, and this one is the base. It's an interesting situation. That concept there of those going together in like a pair is called an acid-base conjugate, which we'll talk about later on in another video. Okay, so that's pretty much the generic what you need to know about acids and bases. Again, there's more things about measuring the acids and the bases that we'll talk about in later videos. If you have any questions, make sure you ask your teacher. Thanks for watching.